Hi everyone, my name is Yuan. I'm going to present my FYP topic, Animated Time Series Data Visualization for Geospatial Events. According to the data growth statistic, 2.5 quintillion bytes of data are generated by human daily. To be precise, 1.7 MB of data is produced every second by every individual. All this massive data can no longer be efficiently visualized by static graph 2. Here comes the problem statement. Static visualization does not provide user engagement and interaction. Most of the visualization platforms have limited sources of data customization. They also lack informative notification. My proposed solution is an animated time series data visualization for geospatial events with 4 modules. They are Data Management Module, Notification Module, Customization Module, and Visualization Module. The objective is to develop an interactive platform that study and evaluate time series data for geospatial events. It is also to introduce animation into data visualization to allow customization on data attributes and to generate informative notification on every animation frame. This is the module diagram. Data Management Module is responsible for data retrieval and data upload. Notification Module is responsible for generating informative notification after processing the dataset. Customization Module is responsible for producing desired output with the help of customization features. Visualization Module is responsible for creating animated visualization with the help of Blockly library. This is the architecture diagram. User can provide input through the front end. Then front end send the request to the backend for application logic processing. After that, backend send response back to the front end and display the result to the user. This is the activity diagram. Firstly, user can upload a new dataset into the database. Then user can select a dataset from the database to create a visualization. Then when a visualization is created, the dataset is used to make extensive calculation asynchronously to prepare data statistics for every animation frame. Informative notifications are then generated and displayed on the front end. User can also modify the visualization by using various customization features. User can always keep looping between viewing the animation and modifying visualization before they delete the visualization. Now let's have a system demo. This is the home page of the system. We can see the slogan, "See the world at a glance." There are 3 buttons on the upper right side. The first one is Position button, the second one is Upload button, and the third one is Create button. Let me demonstrate this Upload button. We can upload a dataset here by selecting an Excel or CSV file. For example, I select this dummy.excel file. The system will show the first 5 rows in the dataset. As we can see here, this dataset contains date column, ID column, and value column. Firstly, we have to choose the date time column. In this case, it is date column. Then we have to name this measurement. I will name it testing. Tag is an attribute to uniquely identify each row in the dataset. In this case, ID column is the tag. Then we have to specify the date time format. This value 2000 is taken from the first row of date time column, which is here. This format will be used to modify the date time column into a standard pattern when it is in the database. As we all know that 2000 is a year, hence the input is %y according to this rule. Let me check the format, and it is valid. I will click this confirm button, and now the testing file is successfully added into the database. We can see the newly added dataset here in the drop down. This testing dataset is the one I've uploaded just now. It contains ID column, value column, and time column. This time column is the pre-formatted date time column with the standard date time pattern: year, month, day, hour, minute, second. Now I will demonstrate how to create a visualization. By clicking this button, a Create Visualization window will appear we must pick a dataset here. Let's pick this dataset, World Cumulative Corona. The system will also show the first 5 rows in the dataset. We can see this dataset contains columns such as confirmed, country or region, depth, lab, long, province or state, recovered, and time. If we want to add an extra column, we can click this add button. Let me name this new column as extra. The new column can have up to 3 operators and operands. The operators are plus, minus, multiply, and divide. The operand can be either the existing columns or number. Let's say I want this extra to be a double of this let column. So for operator 1, I will pick let, and for operator 2, I will pick multiply. Now the equation is let multiplied by 2. Let me click this confirm. Extra is successfully added. We can see the extra column here. There are 5 visualizations types in the system, which are scatter map, density, bar chart race, Choropleth, and carousel. I will demonstrate them one by one. Now let's pick a scatter map. In scatter map, data is represented in the form of a bubble changing in size and color from time to time. Every visualization has its own compulsory parameters. In this case, they are latitude, longitude, size, color, name, and time format. Every compulsory parameter has its own reserved keywords for auto value matching. For example, this latitude parameter has reserved keywords such as lat. So, initially, the system will automatically scan through the column names to check if there is any name containing a keyword. If it is found, it is assigned to the parameter. So, lat column has the keyword reserved by the latitude parameter, so it is assigned to the latitude parameter. For unsigned parameters, we have to manually select the drop-down value. For size, I would like to choose confirm. For color, I would like depth. And for name, I would like province or state. Additional message is an optional parameter where we can provide 0 or more values. For demonstration purpose, I will pick extra and time column. For time format, the system will automatically scan through the time column to look for the best suitable format. So in this case, it is year, month, day. Let me click the create button. So now visual 1 is successfully created. There are 3 sections in a visualization, which are top section, middle section, and bottom section. I will go through the top section later. The middle section is a chart or map. The legend is on the left side. The date time label is on the upper left. Then when we hover over the data, we can see the information. In the bottom section, there's a play button and the slider. When I click the play button, the animation will start. There are notification components where it will slide out when it is clicked. Currently, there are only 3 components, which are maximum, minimum, and percent. From the maximum notification, we can know that Hunan achieved a maximum confirmed number of 1018 on this day, 29 February 2020. As for minimum notification, we can see that Alberta achieved a minimum confirmed number of 0 on this day. For percent notification, we can see this. Ontario shows a positive 83.33% increase in confirmed number from 6 to 11. The notifications are updated when the animation frame changes. Next, I will show density map. Let me pick this thunderstorm dataset and density. All the parameters are assigned, but I want to change this time format to year. Create it. Now, density map shows the distribution of data on certain location. This is the density map of thunderstorm dataset. Next, I would like to show Choropleth visualization. by picking this life expectancy and Choropleth. For location, I will pick ISO alpha. For color, I will pick live exp. For name, I will pick country. Then I create it. Now Choropleth map shows divided geographical area. They are color in relation to data. For the next visualization, I will pick bar chart race by picking crop production dataset. Bar chart race. The parameters are assigned. So now bar chart race is created. You can see the animation of the bar chart race. As for the last visualization, I will pick Hainan urban development and visualization type of carousel. And I create it. Carousel is like an image slider. We can see the time series changes of images from time to time. If we want to reposition the visualization, we can click this position button and reposition it by clicking the arrow. If we are finished, then we can click the position button to revert to the original form. So now the visualizations are repositioned. It is time for the top section. Let me demonstrate this setting. We can download CSV file. This is the CSV file of the thunderstorm dataset. We can also generate MP4. While waiting for the MP4, we can, let me show other functions, such as we can toggle between light theme and dark theme. Okay, now the MP4 is ready soon. We can download the MP4. This is the MP4. Then there are 4 types of map box. It can be strip, light. It can also be satellite strip, and finally the dark map. Then live mode. Let me activate this live mode. Live mode enable the visualization to show real-time update. Let me activate the real-time data simulator. Now we can see the visualization is having real-time updates from the database. It will always show the latest data in the visualization. If I put the slider at the end here, if I pull it away from the end, it will stay on the current frame while the slider is becoming bigger. Then when I put it back to the end, it will show the latest data fetched from the database. Then the name can be edited. I can edit it to whatever I want. Then for marker function, I can insert a marker. Let's say I'd like the name to be USM, the marker. So now USM marker is inserted into the visualization. I can also insert marker by coordinate. Let's say I put latitude as 10, longitude as 10, apply it. So now the marker of latitude and longitude of 10 is inserted into the visualization. Then we can see the information by clicking on to the ID badge. You can see the information, and we can change the color scale. We can also edit the parameter if we want to. Let's say I would like to put this time column as additional message. So now time column is available in the information while we hover over the data. Then we can also add secondary layer. Let's say I would like to pick hurricane event as secondary layer. And for visualization type, there are only two types because secondary layer is only available in scatter map and density. Okay, now secondary layer is successfully added. You can see there are two different kind of data set in the visualization, and the legend for layer 1 is on the top and legend for layer 2 is on the bottom. The layer 2 data start from 2006, so before 2006 there is only layer 1. Then we can see the relationship between two data sets until 2016. Let me play the animation to see the relationship. If we want to remove the secondary layer, we can click this delete button. So now secondary layer is successfully deleted. If we want to delete the visualization, we can click this delete button. So now video 2 is successfully deleted. For impact and benefit, the system can provide better user engagement with animation. Informative notification can keep user aware of the data statistic all the time. User can also customize the visualization to suit their own needs. That's all from me. Thank you very much.